Hello student. In this video I am going to discuss one very important topic in case of system design and analysis that is almost involved in every type of system designing or scheduling a system design or developing in scenario, that is about Pert chart and Gantt chart. Um, this video will be continued till the next video. I'll try to cover almost 50% of this topic today. Then next 50% will be in the next video. So start with the basic introduction of Pert that was developed in the late 1950 in the US. The Polaris submarine missile program. It has the potential to reduce both time and costs required to complete a project. So that US Polaris submarine missile program, they introduced or they used that Pert process, which has the potential, means using that Pert approach they can reduce both time and cost of that project. So actually Pert shows the time taken by each component of a project and total time required for its completion. Try to understand this. Pert shows the time taken by each component of project, total time required for its completion. Pert breaks down the project into events, activity, lays down their proper sequence, relationships and duration in the form of network. So basically Pert is a network diagram which create a network among the events, activities and also lay down their proper sequence of the activities or also events and also durations for each one of them to create that network. Pert is a technique of representing project plan in a network diagram. This is represented in a graphic form known as network diagram. So the abbreviation of Pert is that program, or you can say project, evaluation and review technique. So the abbreviation of Pert is program or project evaluation and review technique, commonly abbreviated as Pert. Is a statistical tool used in project management in the industry level. This is used, which was designed to analyze and represent the tasks involved in completing a given project and to illustrate the flow of events in a project. There are two types of network diagram because Pert is basically network diagrams. So if we talk about network diagrams, we can divide that network diagrams in two parts. That is, one is activity on arrow, second one is activity on node. In the first variant, the duration is denoted on arrow connecting diagram nodes. Such diagram type called activity on arrow, or you can say AOA, where our connecting method is using the arrow symbol. In case of second one, that is activity on node, in such diagram the information about the task duration is denoted in the diagram node, and each task is represented in the form of rectangle with definite set of fields. So in case of activity on node means that network diagram will be created using specific diagram node or node as a rectangle, and in that rectangle there are certain set of fields need to be filled up. Like that way that diagram is created, network diagram is created. Then why do we need the Pert or need of Pert? Using the Pert we can predict the deliverables, means whenever your project or the parts of your project will be delivered, at what amount of time, at what duration, planning resource equipment or resource requirement. You can plan the resource requirement as per the need of the projects or subsystems or sub functions, like that. Controlling resource allocation, you can control the resource allocation. internal program review. You can provide a internal program review. Also, you can evaluate the performance of every subsystem or as a whole system. Uniform wide acceptance. This part, use of part in a project will be accepted anywhere. Also, you can reduce in cost because there is a way to understand, means there might be lots of way to complete a project, but using the part you can analyze which is the shortest way to complete the project or which is the optimal way to complete the project. So in that way you might able to find out which part will give you more reduced cost. And also you can save the time also by following a reduced cost or by following another path in that diagram. Also, you can determine the activities, you can eliminate risk in the complex activities. It has flexibilities, evaluation of alternatives, you can find the alternative path or alternative evaluations. Useful effective control, you can control the whole diagram. Useful decision making, you can decide what to do in the next step because we have already designed the activity diagram. Then, or you have already designed network diagram, then you can decide at what time you will do what. So decision making is useful and also useful in research work. In designing the part or part planning involves following steps. First, it is a cyclic process. You can start at any point of time, but try to start with this one. Identify specific activities and events. Determine the proper sequence of the activities. So first identify the specific activity and the events that are going to be done in case of any system development. Then determine the proper sequence of the activities, means what activity will be done at what amount of time, or is there any parallel execution will be there or not, like that. Construct a network diagram. Then you need to construct that network diagram. In the fourth step, that is estimate time required for each activity. Try to estimate the time requirement for each activity. Determine the critical path. Try to determine the critical path. We'll talk about this term, that is critical path, in the later slide. So first one is identify activities and events. The activities are tasks required to complete the project. The events marking the beginning and end of one or more activities. So you can mark one or more activities as beginning, as end. It is helpful to list the task in a table that in later steps can be expanded to include on sequence is in duration, using as well as the duration. So before creating that before getting that part diagram or network diagram, you can list out all the activities that are going to be carried out in a project in table. So later, one by one, you can choose which will be done at what time and which will taken at what amount of duration. So in that way, you can arrange them in that network diagram, and it will have a beginning and end of that diagram. So you might assign beginning activities, and you can assign ending activities. So there might be one or more activities like that, beginning or ending. Second one is determine the proper sequence of the activities. Next, after finding the number of events and identifying the activities or events that are going to be held during the project work, you need to determine a proper sequence of those activities. These steps may be combined with the activity identification step, since the activity sequence is even for some tasks. Other tasks may require more analysis to determine exact order in which they must be performed. In the third, construct a network diagram using the above information that has been used in case of number 1 step and number 2 step. You draw the network diagram. Using the activity sequence information, a network diagram can be drawn showing the sequence of the serial and parallel activities. for the original activity. For the original activity on our model, the activities are developed by arrow lines, milestones are depicted by circle. In the fourth stage, estimate the time required for activity. You need to estimate the time required for each activity. That might be your guessing time initially. A distinguishing feature of Pert is its ability to deal with uncertainty in event completion times, in activity completion times. So for each activity, the model usually includes three time estimates. You can use three types of time estimates because you need to decide what amount of time will be given for each activity. Like you can go for optimistic time, generally the shortest time in which the activity can be completed. And again, you can put most likely time, the completion time having the highest probability. Note that this time is different from the expected time. So there is the difference between most likely time and expected time. Means most likely time means how much highest amount of time might take a event. Pessimistic time, the longest time that an activity might require. This is the longest and this is the highest than most likely time. Determine the critical time, that is the fifth step. The critical part is determined by adding the times for the activities in each sequence and determine the longest part in the project. So critical part is the longest part in the project. By summing up the activities in a network diagram or summing up the activities in a part that is found in the activity diagram, that in the part diagram or network diagram, and which will come longest part, that will be your critical part. The critical part determines the total time required. So critical part always determines the total time requirement for the project. In the sixth, update the pie chart as the project progresses. So whenever the project progresses, then you need to update the pie chart because sometimes time might be exceed or time might be reduced at some point of time. So that need to be updated in pie chart because it will give you more updated value of the completion time. So advantages of pie chart is that simple to understand and use. So whether project is on schedule or behind or ahead of the schedule. Identify the activities that need closer attention, means you need to analyze how much amount of time it will take, how much cost it will take. Using this pie chart diagram, you can identify those activities. You can give some closer attention. Determine the flexibility available with activities. You can decide which activities are more flexible in case of time or in case of cost or in case of resource using, like that. So potential risk with activities, also you can decide which activities might provide or might provoke more risk. Provide good documentation of the project activities. You can provide good documentation having the pie chart diagram. Help to set prioritize among activities and resource allocation as per priority. There are various applications of pie chart like used in research development projects, for developing tooling and introducing a new project, the plan and execute the acquisition and installation of an electronic system, development and administration of various training programs for management development and organizational planning. There are also some limitation of pie chart. A major disadvantage of Pert has been its emphasis only on time, not on very much on cost. But having the knowledge of time also, we can find out the cost. But directly the diagram of will not show you the cost, but you can evaluate that cost using the time. The cost of setting up such systems are extensive. So if you use Pert, it will take lots of amount of time because the whole thing will go on until the project ends. It is difficult to estimate accurate time and cost of various activities involved in a project. Errors in estimation makes the Pert chart unreliable as a control aid. So sometimes it is very much tough to set some time for a specific activities, and then it might create some errors or it might be unreliable. These systems will not help managers to solve all their problems. So example, to perform an operation for a patient. Suppose this is the example. We need to perform an operation for a patient. So Then activity will be like prepared present. Events is like activity is prepared present. Events is, for one activity there might be lots of events also. Patient prepared. Given anesthesia, activities given anesthesia, events anesthesia given. Activities prepared instrument trolley, events instrument trolley prepared. Activity perform operation, events are operation perform. So suppose here prepare patient, that is one first step. Second, and you can directly go for anesthesia given, and again in the parallelly you can go for lay instrument trolley. So that is another part from one, and again in the fourth step, that is operation perform. But that can be given also, this lay instrument trolley can be given also from this point. So this is just a brief example of network diagram for the analysis of the part, where we try to do this first activity first, then second, this is second activity, and this third is going from one as a parallel as shown here, and the fourth is perform operation perform. So this is one example. I will try to show more one more example in the next video, and I will try to start with Gantt chart in the next video, because this is also one type of charting technique just like the Pert chart, but I will give a more descriptive example in case of Pert in the next video. Till then, if you have any confusion or question to ask, or anything to add, or anything to share, please let me know. We'll try to do that over Google Meet. Thank you.